While the world was sleeping this weekend, the landscape of human intelligence changed forever. In the heart of Austin, Texas, at a site now known as the Terafab, Elon Musk just fired the starting gun on what he calls the most epic chip-building exercise in history. We've seen gigafactories, we've seen Starbase, but the Terafab is something else entirely. It's a $25 billion joint venture between Tesla, SpaceX, and xAI with one terrifying goal: to produce 1 terawatt of AI compute every single year. To put that in perspective, that is roughly 50 times the current output of the entire planet. If the global chip industry is a garden hose, Musk just unveiled a waterfall. But it's not just about volume, it's about vertical integration. Musk is doing something no other company, not NVIDIA, not TSMC, not Samsung, is doing under one roof. He is bringing logic, memory, high-end packaging, and testing into a single seamless pipeline. No more shipping wafers across the ocean. No more waiting in line for third-party allocations. This is the bridge to what he calls a galactic civilization. And with the film Project Hail Mary trending, Musk's vision feels less like a corporate keynote and more like a survival plan for the species. Today, we're going inside the Terafab to see how Musk plans to move the brain of the world into the stars. So, what exactly is being born inside this 100 million square foot monster? Musk is splitting his focus into two distinct silicon lineages. First, there's the AI5 and AI6 chips. These are the ground troops. Optimized for edge inference, these chips are the brains for the Tesla Cybercab and the Optimus humanoid robots. They're designed to process the messy, chaotic physical world in real time with ultra-low power consumption. But the second lineage is where it gets wild, the D3 space-grade chip. Most people don't realize how hostile space is for electronics. Radiation flips bits, and heat is a nightmare to manage without an atmosphere. The Terafab space-grade chips are built to run hotter and tougher. These aren't going into cars. They're being loaded onto AI mini-sats, 100-kilowatt orbital data centers launched by the hundreds of thousands via Starship. What is Terafab? The primary goal of Terafab is to produce 1 terawatt of AI compute capacity annually. This figure is staggering, roughly 50 times the total output of the entire global semiconductor industry today. To reach this, the facility aims for 1 million wafer starts per month, a volume that would rival the combined global output of current market leaders from a single site. Vertical integration under one roof. Unlike traditional chip manufacturing, which is fragmented across different continents and companies, Terafab is designed to be fully vertically integrated. The facility in Austin plans to handle every stage of production in-house: logic and chip design, creating the architecture for custom AI silicon; lithography and fabrication, etching the chips using advanced 2-nanometer process technology; memory production, building high-bandwidth memory directly into the stack; advanced packaging and testing, finalizing the chips for immediate deployment. Why move AI to space? Perhaps the most shocking part of the announcement was that 80% of Terafab's compute is destined for space. Musk argued that no one wants AI data centers in their backyard due to their massive noise, heat, and power demands. Solar power. In orbit, solar energy is roughly 5 times more intense than on Earth and available 24/7. Cost efficiency. Using Starship to launch thousands of solar-powered AI mini-strats, Musk expects space-based compute to be cheaper than ground-based systems within 2 to 3 years. Ultimately, Musk views Terafab as the foundation for a galactic civilization. By creating an infinite supply of cheap AI and robotic labor, he believes we can enter a post-scarcity era of amazing abundance for everyone. Musk made a pointed comment during the reveal. No one wants an AI computing center in their backyard. And he's right. Data centers are loud, they consume massive amounts of water for cooling, and they are putting an impossible strain on our aging power grids. Musk's solution? Leave the backyard entirely. In orbit, it is always sunny. You have constant 24/7 solar irradiance, roughly 5 times more powerful than what reaches the Earth's surface. By using vacuum cooling and constant solar energy, Musk predicts that within 2 to 3 years, the cost of space-based compute will actually undercut the cost of building on the ground. Think about that. We are moving from the cloud being a metaphor for a warehouse in Virginia to the cloud being a literal constellation of millions of satellites orbiting overhead, processing the world's data using the raw power of the sun. This is where the rich part of the vision comes in. Musk isn't just trying to beat NVIDIA. He's trying to trigger a Kardashev Type II transition. The scale of Nikolai Kardashev, astrophysicist, 1964, classifies civilizations according to the amount of energy they can use. Type 1 masters the energy of its planet. Type 2 masters the energy of its star. Type 3 masters the energy of its galaxy. Literally, now we are civilization Type 1, and Elon Musk wants to push us to Type 2 civilization capable of harnessing the full power of its star. He's talking about a post-scarcity economy. In Musk's view, if you have a terawatt of compute and a billion Optimus robots, the cost of labor and goods collapses towards zero. This leads to abundance for everyone. We've made video for that subject if you are interested. Link will appear on the top of the screen. He even teased the long game, mass drivers on the moon, using these chips to coordinate electromagnetic railguns that can launch resources from the lunar surface into deep space. It sounds like the plot of a sci-fi novel, because frankly, that's the scale he's playing at. He's building the hardware for a civilization that hasn't even been born yet. The critics will tell you that building a 2-nanometer fab from scratch is a Herculean task that has broken bigger companies. They'll point to Elon time and say these satellites are years away. And they might be right. But the need for AI scaling is real, and the resource wall on Earth is closing in. Whether the Terafab succeeds in 2 years or 10, the statement has been made. The era of terrestrial-only computing is ending. Elon Musk has made a career out of ignoring what the industry says is impossible. With the Terafab, he isn't just betting on a factory, he's betting that the future of intelligence belongs in the stars. The Terafab is the first brick in a galactic foundation. The question is, are we ready for the abundance it promises, or the power it grants to the one who owns the chips? Would you trust your personal data to a satellite network orbiting 300 miles above your head? Let me know in the comments. And if you want more deep dives into the future of the Silicon space race, hit subscribe. I'll see you in the next one.